This lab will be looking at the del keyword. So here I have declared a variable. X is the variable name and the value is 10. And then I am printing the X value just by putting it on the next line. So this works in Jupyter Notebooks. So this line over here where you just put the variable name works in Jupyter Notebooks and not within Python scripts. So if I run this over here, you can see that the value here is 10. But if I now use the del keyword and delete this variable, so if I delete that, that statement has run. Now, if I try and print the value of X, you will get a name error. The name error is name X, which is this variable, is not defined. So basically, Python no longer has this variable name in the memory. So what it does is the del keyword deletes the variable name. So here by using del X, it deletes the variable name, and accessing it after gives us an error. So here you can see we've got a name error to say it's not defined. And the value that we had X equal to 10, that value is gone if there are no references to it. Because we have declared that here, X equals 10, there are no further references to it, so this value has been garbage collected. So here, another example here, what I want to demonstrate is references. So references are removed and how Python works with them. So here we have another variable, and this variable points to a list over here. So this is going to store a list. And then you have the B variable, and the B one is pointing towards A. So B over here points to A, which is over here. So in turn, A holds this value. So B also has these values. So if I were to print these two, so here I've just printed out the values of A and B, and you can see they are the same. So now what we're going to do is we're going to delete the A variable. So if I delete that, and what do you think B will still have? Will B still exist? So if I run this over here, yes, B still exists. But if I try and run A, you can see that A doesn't exist. There is a name error. It's not defined. But B continues to exist and it still points to this list over here, even though A has been deleted. So remember, B over here is actually referencing the original memory location where this list is stored, where this data over here is stored. So in summary, using the del keyword, it removes a reference. So A no longer can access this list over here. Python then checks, are there any other references that point to this object? So this list is an object. So are there any references? Now in this instance, B was referencing this. So it goes to yes, that there are references. So I will keep it in the memory. But if there were no references, the object becomes garbage collected. So if, for example, you didn't have this one, or what you did was you also deleted B. So if you deleted B and then basically it got rid of this list as well, eventually it will be garbage collected. So just remember that del does not force memory cleanup. Python's garbage collector decides when the memory is actually reallocated. The del keyword remove references. Memory is only freed when there are no references to the main object. So here, this object, it will continue to exist as long as B references it. But if I delete B, then this object is gone. So this data over here is gone. In this lab, we'll be looking at the del keyword. The del keyword can be used to remove an item from a list. It uses the index number and it shrinks the list immediately. So we know that the del keyword is used to delete a variable. So here we declare a variable and then we can use del keyword to delete this variable that we declared. So if I run this over here, you can see the value of X is 10. But if I now delete this and here, this variable is deleted. So if I now try and print X, then you will get an error to say X is not defined. So del keyword here is used to delete variables. But did you know you can use it on lists as well? So here I have a list. It contains 10, 20, 30. Lists are defined by the square brackets, as we know from the past knowledge I have shared. So here what we want to do is delete the element at position 1. So at position 1, this is position 0, this is position 1. So it will get rid of this value over here. So 20 will disappear. So we will only end up with the values of 10 and 30 in a list. So if I run this code over here and see the output. So here you can see the items that we get back are 10 and 30. So the item which has 20 has disappeared. So here the del keyword is removing one item. It uses the index number and the list shrinks immediately. So when I print the list, you can see 20 has disappeared. So this is done by a position number or the element number, which is also known as the index number. But you can also use it to delete multiple items like this. So here we are going to delete multiple items items, we are going to use the slice notation. And what will happen is the remaining items will stay in order. So here you can see I have a variable called letters. This again is a list denoted by the square brackets. It has the items A, B, C, D, and E. Then we're going to use the del keyword and we're going to use the variable name. And in the square brackets, we are not going to put one index like we did here. Instead, we're going to put 1 and the colon and number 4. So that's saying start from index 1, go all the way up to index 4. So that would be 1, 2, 3, 4. But one thing that you need to consider is the item at position 4 won't be deleted. So the 4 here says up to 4. So it is up to from 1 up to 4. So only this part will get deleted, not including the actual 4th position. So in effect, this is doing 1, 2, 3. So it will keep the E and it will keep the A. If I run this over here, you can see the output that we get is A and E because we said position 1, 2, 3, and 4, but it's up to 4. So it doesn't actually include the 4th element. So use this notation to delete multiple items. Just use a colon. So that basically says 1 to 4 versus using a single index. So here it deletes multiple items, uses the slice notation. So this over here is a slice notation and the remaining items stay in order. So as you saw, A and E continue to be in the order that we defined them. It just got rid of B, C, and D. In this lab, we're going to be looking at del keyword on a list item and also the difference between the pop function that you can use. So here you can see I have a list of items. The list contains 3 items, the numbers 1, 2, 3. You can tell it's a list because it's denoted by these square brackets. So here you can see that del will remove an item, but it returns nothing. So here you can see we're using the del keyword. We're supplying it an index of 1. So this is index 0. This is index 1 and this is index 2. So it's 0 based index. So it's going to remove the number 2 from this list. So if I run this, and you can see that number 1 and number 3 remain. So number 1 and 3 remain while 2 have been got rid of. But with del keyword, it doesn't give you back anything. So here, there is nothing that comes back. And if you're thinking maybe you can put like a variable name in here, then will it give you back anything? So you can see that we get an error. It says the index is invalid. So here I've done it to match this one. So you can see that actually it's not the variable name or anything. This index is essentially invalid. So you cannot do that with the del keyword. So if I get rid of this, so it doesn't really give you back anything. So you cannot store the value. But with the pop method, you can. So what you need to remember is del removes and returns nothing. Pop removes and returns a value. So you get something back. You use the del keyword when the value is not needed. So here, if you do not need the number 2 back or the element 2, then use the del keyword over here like this. Use the pop if you do need the value. So if you want the value, use pop like this. So if we run through this one, so if I run this code over here, you can see that when we remove the element 1, which is again this item over here, we actually get it stored in this variable, which you couldn't do with the del keyword. So now you can print the removed item and you can see it's number 2. And then you're left with numbers 1 and 3 over here, which is 1 and 3 there. So use pop, it removes one item and gives it back. You can store the removed item in a variable, which we did over here. So you can see when we did pop, you supplied an index number and it stored that number within the variable. So using pop when you still need the value. So between these two methods, in summary, use del when you want something gone. So if you don't want anything to do with its number 2 or the element 2 there at position 1, then use the del keyword. Use pop when you want to get the value back. So here we do want to store this element. So we used pop and stored it in a variable. So we want to do something with. In this lab, let's have a look at the del keyword and how you can use it against a dictionary. So here we have a dictionary. This dictionary have the following keys: name, age, city. So these are known as keys, and then the values for these. So name is the key and the value is James. Age over here is the key, the value is 25. City is the key, value is New York. So here what we want to do is we want to get rid of the age. So we want to get rid of age over here because we don't need it. So just imagine you getting some data back and you've got the data in a dictionary and you go, you know what, I don't need the age. So in order to get rid of the age from a dictionary and free up memory, what you can do is you can use the del keyword, give it the variable name of your dictionary, which in this case is person, and then in the square bracket, give the key that we want to delete. So here, age is the key and age is over here. So it must match. So we can do that. And then it will delete the age. Actually, if I print the dictionary before and after, so if I show you that, so you can see here what it's done is before we had age in here, but now we only have name and city as the keys and their values. So it's got rid of the age key and age value. So essentially, here's del remove one key and its value. So this value over here is also gone. You must give the key name to delete it. So in here, the key name we gave is age. You don't have to give it value, just the key. And the important bit is the key must already exist. So you cannot have a key that doesn't exist. So if I show you that, if I put age, or let's just put country. So country we know does not exist in any of the keys. So if I were to run this, then you see we get a key error to say that key country doesn't exist. So the key must exist. So here you can see the dictionary updates immediately, which is true. So as soon as the del keyword is run, then you print the person again and you can see the age has disappeared from the keys. And remember, the del keyword doesn't actually give you back the value. So if you want the value back of what you've just deleted, then you need to use the pop method for the dictionary. Del's purpose is to free up memory. So if you've got large items that you're storing and you want to free up memory, del will get rid of the reference for that. And then finally, the garbage collector for Python will eventually free up memory. In this lab, let's talk about Python sets cannot change, but you can add additional elements or values to them. So here you can see that I have a set. The set, of course, is donated by the curly braces here. So you can see they are comma separated. And this, although looks like a dictionary, but remember, this is not a key value pair. It is basically a list of values, but surrounded by these curly braces. So they look similar lists as well, but lists are by the square brackets rather than the curly brackets. So the unique properties of sets are that a Python set stores unique values and it doesn't care about the order. So what you may think of is set is a collection of unique values. So here we have unique values. Red is different to blue. So this string is different to that string. So here, if I run this, you can see when I do that, then red and blue appear. So what you can do is these red and blue, they cannot be changed. Then you cannot change its items, but you can add new items. So here I can, for example, add to the same variable. So colors is the variable over here. I can add an additional item such as the green color. If I show you that, you can see now we have green, red, and blue. Now the order in this instance has happened like this, but do not rely on it because sets internally by Python are stored in different buckets. So do not rely that they will appear as though you input them. So in that order, do not rely on this, and this being the third element. So in order to add an item, you basically use the variable name and the function or the method add. So add will insert one value. Syntax for it, as you saw, is basically the item within this function. So set dot add value, which is there. This is the set, and then this is the function we're calling and the value we are passing. Duplicates are ignored. So here you can see when we try and add red, but red already exists. So previously when we added green, you can see green got added over here. So now if I run this over here, and you can see that we still have green, red, and blue, which is what we had here. So the additional red has not appeared in this list. There is only one red value here. And the important thing is this line didn't cause any errors. So no errors occur if the value already exists. So this value red already existed when we created a set and it caused no errors. You can see it just worked. Final thing to note about sets is you cannot choose where the item goes. The set will internally decide the placement of anything that you may add. So any items you add, it will decide which order they get added. So the order may look random, but this is expected. So if I were to rerun this program a few times, I'm going to restart the kernel. So what I want you to remember is red and blue appear like this. So you end up with this combination, which is green, red, and blue. So if I restart, and now if I run this again, and now you can see the order has changed. We now have green, blue, and red. Whereas what I originally did was we had red, blue, and then we added green. But notice here, green is the first item, then it's blue, then it's red. So just by restarting the kernel, the computer automatically changed how it was gonna place them internally. So this is important. The order may look random, but it is expected, and you cannot choose where the item goes. Set decides the placements internally. This is very important to understand with sets. In this lab, we're going to look at adding multiple items to a set. So previously we looked at using the add method, but there is another method which is called the update method that allows you to add more, and I will tell you what the difference is between them, which may surprise you. So use the update adds many values at once. It accepts lists, sets, and tuples. So these are the different data types in Python, and the syntax for it is pretty much same as the add method. So here you can see update method, we pass it in a list over here. A list is an iterable type, so you can pass in any iterable type, and duplicates are still ignored. So let's work through this practically. So here you can see I'm gonna create a set of colors. So there's 2 items initially in that set. Then I'm gonna add 1 item, which is the color green, using the add method. So that's just adding a 1 method, and you can see now our set has 1 more item in comparison to what we had previously. Now you might think then you can use the add method again and just pass in 2 items rather than 1. This won't work. So if I run this, you can see that we get an error to say that it takes in exactly 1 argument where 2 arguments were given. So that's a type error. So this won't work. Instead, what you can do is you can declare your new colors. So here we want to add in the purple, orange, and we want to add in the blue color. Now notice here blue is a duplicate, so blue already existed in. So if I run this, then duplicates will be ignored. So here there is only 1 blue, as originally it's added in orange, it's added in purple, and originally we had red and green. So green was added in as a single item over here. So duplicates still got ignored with the update method over here. So you might be thinking, why have the add method and the update method when actually update method I could just put in 1 item? So let me show you what will happen. So here we added green within here using the add method. So if I now add using the update method, so here I've got the update method and I'm going to add the color black. So here I've added the color black, and now I'm going to print. So I'm going to print the colors. I'm going to add the black. So this syntax pretty much looks the same as the add method, but you've got the update method here. So what will happen is if I run this, something strange has happened, which you probably didn't expect. So here, although the syntax is same, what you will notice is we suddenly have some weird things going on. A, C, B, L, K have been added in, but there is no mention of a red color anywhere within here. So the black hasn't been added. So the black color that we tried to add has simply not appeared. Instead, we've got some letters. So what this has done is it's changed by using the update method, is treating it as an iterable item. So what we mean by that is set takes in an iterable. Since a string is something you can slice and dice and loop through. So when it's done that, then it's split up the string over here into individual characters and added that. So this is the reason why the add method exists versus the update method. In this lab, let's take a look at the difference between remove and discard method on a Python set. These are 2 important methods, but there is a big difference that you need to be aware of. So here you can see I have a list of colors. This list of colors is actually a set data type. So you can see it's a set because of these curly braces. Then what the remove method does is it removes 1 specific value. The value must exist. If the value is missing, the what value that you're trying to add, for example, if blue was missing, you will get an error. So Python will stop with an error when that happens. So when you get an error for a missing value. So let's demonstrate this on the screen. So if you click on play, and if I click on play, and you can see that we've got the following output for our set over here. It's got 3 colors, and now we want to remove the color blue, and then we will print the colors again. So if I run this over here, you can see that we now just have green and red. So blue has been removed because we used the remove method and passed it the string we want to remove or the item we want to remove. If we try and remove something that doesn't exist, so yellow doesn't exist in our list over here. So if I run this over here, what you will get is you will get an error. This error says it's a key error. It cannot find yellow. So Python here has stopped, as you can see over here. So the alternative to the remove method is the discard method over here. So what we'll do is we are going to again create the same number of items in our set, and we are going to discard the blue one and then print the list. So if I run this over here and run this, and you can see that there's been no issues in removing the item blue. So if the item is found, it removes it from the set. Now the important difference here is missing value. So with the remove method, you can see that we got an error. With the discard method, nothing will happen. No error is raised and program continues to function as though the error never happened. So if we go here, so now what we're going to do is we're going to try and remove the yellow color. We know yellow doesn't exist in our items. So if I run this, and you can see that the program is success. The green and red still exist and there's no issue. Yellow wasn't not found and it didn't raise any errors. So no errors were raised, program continued. So that's the difference between the discard method and the remove method. Remove method did a key error, discard method didn't do an error. So if you want the error to happen in your code, so you definitely want to know that something failed, removal of something failed, something important, then use the remove method. But if you go, actually, I don't care if the item was not found, then you should use the discard method. In this lab, let's have a look at the pop method and also look at the clear method, as well as looking at discard and remove methods. So here I have a variable that holds a set. A set is denoted by these curly braces. I've got 3 colors in here. So if I run this, you can see that I have 3 items within this set. If I want to use the pop function, what the pop function does is it removes one random item and then it returns the removed value. So in this instance, it will randomly remove one of these colors and then store that item in the return statement there, and I'm going to print it over here. So if I run this code over here, you can see that we get randomly, it's removed blue. Notice here when we created the list, blue was in the middle, but Python set put it at the beginning and the pop method removed the blue color. This may not be in the same order that you expect, so it's not predictable. Different items could be removed at each run. So if I were to restart the kernel, then potentially a different color could be removed. This is because sets have no order. So pop remove an arbitrary item. So just as we didn't know which one was going to be removed by pop. Remember, if you're running this code in an automated fashion, you won't necessarily do a print statement and see the order of the items. So with pop, you won't know which one has been removed. The next method is the clear method. This one, it would remove all the items in the set. The set will continue to exist, but the result would be an empty set. So essentially it will empty out the set. So if I run this on the variable colors, the clear method, then what will happen is the set becomes empty and it's cleared out all the elements that we had remaining. So in summary, you've got the remove method, which says item must be there for removal. So if I try to remove yellow and it doesn't exist within our set over here, then it will error. So here I have just run this again to populate the set with the following items. And now I'm going to run the remove method and you will see that it's saying that yellow doesn't exist because we only have blue, green, and red in the set. So with remove, the item must be there. With discard, the item might be missing. It has the same function as remove, but it won't error. So if I change the discard here to black, then you will see that black doesn't exist in our list. So here we don't have black in this set, but you can see the code has successfully executed and there are no errors, while the remove method would error. And as you saw, the pop method removes any one. So it removes a random element from your set. You won't know which one it is, but it does give you back the element it is removing. And finally, the clear removes everything. So here, when you do a clear, then you basically end up with an empty set. In this lab, we are going to look at the for loop for sets. So here I have a variable called colors. This is going to hold this set, and you can tell it's a set because of these curly braces. And then I have the following items in my set. Remember, set stores unique values, but unlike list, don't remember the position. So the syntax for the loop is the following. You use the for keyword, then you have a variable name. This is something you can make up. So I've called it C, but you can call it color, for example. Notice it's different. This is color, singular. So one color versus colors here, which is the variable over here. So for each color in colors. So here you've got colors, that's that variable. So for each of these colors, it's going to do something. And then what I've got it to do is print it. Now, notice here that there's a syntax error. This is because I changed the variable here, the temporary variable. So I'm going to change this to match the variable here. So for each color in the colors, we're going to print the color name. It's going to go through and loop each item per loop past. So every time it goes round, it will go through the different items. There are no index in this, and the same item will never repeat again. Now, if I run this code over here, you can see what we have is blue, green, and red. Notice that the way I set the setup was red was first, then it was green, then it was blue. But with the output, blue has been printed first. So this is important to understand. So the print order can change, and this is normal for sets. So if your program depends on order, set is the wrong tool. So do not use set if you depend on order of things to be printed. So as you can see, if you wanted red to be printed first, then set is the wrong tool to use. Do not use it. But the advantage with set is it doesn't allow duplicates. So we never have to worry about the same scores being printed twice. So here you've got the scores of red, green, and blue. So you will never have to worry about them being repeated. So as you saw, you will not get any duplicates. Now you can see I talked about that the order may change, and this is normal for sets. So you can see here current order is blue, green, red. So if I restart the kernel, so just imagine your program runs again. So if I restart it, click restart over here. So this is now restarting. And now if you remember this is blue, green, and red. If I run this again, you can see the order just changed. It's now printed red, green, and blue. And if I do that again, restart, so the program is going to run at a different time, and you can see the order has changed again. So that's why when we say if your program depends on order, set is the wrong tool. So what I mean is the set syntax is the wrong tool for you to use.